In this edition of Water Drops, we're going to look at building an InfoWorks WS Pro model using a Civil 3D drawing. So who is this for? I was trying to come up with some different options, but really it's for anyone who wants to build a hydraulic model leveraging your available DWG files. So whether you have an AutoCAD drawing, a Civil 3D drawing, all of these can assist you in building a model. The workflow we're going to look at is creating a model group, import the layers from DWGs, and then we're going to clean up the model using the available InfoWorks tools. Now that we discussed the workflow, we're going to go ahead and hop into the software and walk through it. So as you can see, we're going to be working in WS Pro. And the first thing you'll probably notice is that how it's laid out is a little bit different because we actually have a master database that holds all of our model groups, which can act as projects. This is really a big advantage to the work group set of products, because this allows you to share information like themes, SQL queries, validations, and inference tools across these projects. So once you create your first project, walk through, you can then continue to use those on future projects without having to recreate your efforts. Another advantage to the workgroup products is the ability to track changes through data flags. And that's where we're going to start today because we want to go ahead and set up 2 data flags. As we can see, we already have Civil 3D for coming from our Civil 3D data, GIS, inference, and model edits, but we want to add 2 more. We're going to add AS for assume data. We're also going to add my initials so we know that I was working in this model, and if someone comes in behind me, they can see the changes that I made. So now that we have those knocked out, we can go ahead and create our model group and our model. So we'll start with creating the model group. We'll go ahead and start by creating our network. So we'll go ahead and open our example network, and the first thing we're going to want to do is set the location. So this coordinate system will allow us to make sure we're working in the same place. Everything we're importing will be in the proper place. And we're also going to turn on some background imagery to ensure that we're working in the right place and just making sure all those line up when we import. So we're going to go ahead and we're going to be working in the Colorado Central Zone. So now that our model the geolocation has been set on our model, we can go ahead and bring in our information from a DWG. So we're going to go to the network import from AutoCAD DWG. I'm going to browse and go to my DWG. And this is going to populate the layers that are within our drawing. And what we want to find is where our water line is. So what we are telling it is for on the sea water pipe layer. If we choose it, it will bring in 1,549 polylines. That's what's within that layer. That looks like how we want it. So we'll go ahead and assign the pipes to the seawater pipes. And then we also want to tag it with the Civil 3D data flags. So we'll go ahead and press OK. And now, as we can see, it has brought our model in. But let's say we want to confirm that we are working in the right place. So we want to bring in some background layers, and we're going to leverage web map services to do this. But we also want to have a clean model with nothing in the background when we're working to have less noise, less distractions. So one of the things that we are going to create is we are going to create a layer list group. And this is just going to save our current layer list, which is just our model with nothing in the background. And so we'll create a new layer list and call this no background. And then we'll create another one with the background on. So we're going to go ahead and go to layer controls, and we're going to add web map services. This allows you to point to a URL and be able to pull that information in and have that in the background. And so we'll go ahead, as we can see it's visible, we're going to go ahead and apply and OK. And now we can confirm that the water line is in the area that we want to work in. We're going to go ahead and save this layer list as well and call this with background images. That way, if we want to turn this on and off throughout this video, we can. So we've confirmed that we are working in the proper place. We have brought in our model. Let's go ahead and turn off that imagery and start making updates. So we're going to go ahead and zoom in, and as we can see, we have multiple nodes. So when we brought in the DWG, it put nodes at the end of each pipes. So when pipes come together, it is going to have multiple nodes stacked up on each other. So we want to go ahead and do some cleanup. So there's a couple different ways we can do this. We can use our inference tools to fill connectivity. We could use some SQL queries. We could also use some of the tools that are built in when it comes to tracing tools and doing connectivity trace or proximity trace. But one of the advantages of the InfoWorks products is you have the ability to run Ruby scripts. And I'll use this as a time to plug our GitHub site that has a lot of these Ruby scripts on hand. So what we're going to do is we're going to go to network and we're going to run a Ruby script, point to the Ruby script. Here it's called cleanup. Go ahead and open it. And now when I zoom in, we are now just getting one node at the end of the pipe, exactly how we would expect. So next we're going to go ahead and look at our links. So if I open this link, we're going to see the first example of the inline validations. So this is telling us that we are missing a diameter on our pipe as well as a friction coefficient value. So we're going to want to go ahead and clean those up. So we could do this by bulk editing. We could do this by individual editing. But what we are going to do today is go ahead and use some of the SQL queries that you can build within InfoWorks WS Pro. So we're going to go ahead and create a new stored query group. We're just going to give it the standard name. As you saw on that screen, when you create a stored query group, you have the ability to load factory queries. So there are built-in queries that you can pull in right away if you want to use those or just want help with building them. So I'm going to have a new stored query. We're going to do this set diameters to 6 inches, press OK. And then we're going to go ahead and open this up. And so we want to set all of the diameters within our network to 6 inches. So we're going to type set, and I could type it all out, but we also have these builder tools. So we're working with all of our links. And if we go to the field, because we're working with diameter, we want to set all of our diameters equal to 6 inches and press OK. This is where we're going to go ahead and test the syntax. It says it's available to run. We can press OK, save it, and we can either run it from the screen or we can drag and drop. And now when I press on my links, the diameters are set to 6 inches. The next thing that we're going to want to update to ensure that we can clear this validation messaging is assigning friction coefficients. Now, once again, you could go do bulk edits through the link window, make editing all of them, but why not leverage the tools that we have at hand, where we're not only just going to set these coefficient frictions, but we are also going to change the friction type. So we have both of those built out, set our friction to HW, set the coefficient to 110, and now when we zoom in, these were set to the values that we saw fit, and we were also able to assign data flagging. And this was done if we open up one of these by adding, you can have multiple rows of telling the SQL query what to do. And so we have another one with the 6 inch diameter that has assumed where the diameter is greater than 0. So we're going to go ahead and use that one. And now, as we can see, the flag was updated for that as well. So those are very simple queries, but some of the stored queries and the default queries in there can get a little bit more complex. This is definitely a tool that you can dive into and spend some time and really build those out. So now we're not seeing any more of the inline validations, nothing that's popping up in this row telling us that we need to update. So let's go ahead and validate our model. So we have a tool, and the validate is going to go ahead and check for missing values and issues within the system. So if we press OK, we are coming up with a issue. And as we can see, this network must have at least one reservoir, fixed head, or well object. So we have no place where water is actually coming into the system. So we are going to go ahead and come to this node and say that this is where our fixed head is going to be. We're going to change the type of this node by choosing this button in the top, change that to a fixed head, press OK, and now we are going to go ahead and validate the model. So as we can see, we have brought our information in. We have also updated all of the diameters in our network, made sure that it was validated, used SQL queries. So this is a model that we can start bringing in demands, customer points, and really start running this model when that information is in. The next couple steps are going to be optional, how you can build this out a little bit more. So the first thing that we're going to go ahead and do is we can see that we are missing elevations and ground levels at our nodes. And so what we're going to do is we're going to go ahead and bring in a ground model. So let's say we were working in a very similar area on another project, and we can go ahead and bring that ground model in. So as we can see, it takes up our network. And this is where we're actually going to use our inference tools that we are pulling from another project. So similar to the SQL queries, the ground model, all this information can be pulled from a different project. This can be shared between projects, really limiting the time it takes to recreate work. So if we open up this inference tool, as we can see, what we're doing is we're setting the ground elevation and setting the elevation and the ground level using the ground model, and then also filling in with some surrounding nodes when needed. So we'll go ahead and close this. Oh, and another thing to point out is once again tagging with that flag value of this is an inferenced. This comes from an inferenced value. So we're going to go ahead and drag and drop. And because I had this selected, it only updated that one. So we're going to unselect, drag and drop, and run it on the entire network. And now when we zoom in, now our ground elevation and our ground level and elevation were set for our nodes. So now that we have made this change, we're going to go ahead and turn off the ground elevation. We no longer need to see that, and we're just going to change the display. So it's still in there, but it is no longer on. And so the next step that we are going to go ahead and do is add some pumps and change some and assign some links to be pump stations. So if we go to a new link window, this is where you're going to create pumps, because within WS Pro, pumps are actually links. So we're going to go in, create P120. Go ahead, we know that we have a nominal flow of, let's say, 1.73, a nominal speed of 2000, 6 inches for both, and we're going to go ahead and generate a curve, pump curve. So we have a couple different options. We can do an InfoWorks 1 pump, EPA Net 1, EPA Net 3, or a WattSys Watt Max 3 point. We're going to do an EPA Net 3 point. So let's go ahead, set this to 360, 315. So we have those values, and we know that it's generated a curve. Go ahead and change this to 0.1, apply, press OK. And now that we've created the pumps, we want to go ahead and change a link or multiple links to pump stations and assign that pump curve to those. Let's say we know that our pump stations are right here. We have the ability to right click, selection tool, selection options, change type, and change this to a pump station. and press OK. And now when I open one of these, as we can see, we are now at pump station, but we're also getting a validation issue because you must assign a pump to a pump station. So we want to come in, choose that pump 120 that we just created, plug in the information that we know, so that validation went away. We are going to assign a duty head and an electrical mechanical range. So we want to go ahead and tag this because I am updating it with HS. Set that to 350, 1.25. And we are going to do the same here. Match these values. No more errors, and then we will go ahead and run through and validate this model again. So we're not getting any issues. If we want to take this a little bit further as far as using validation tools, you also have the ability to create an engineering validation, and the engineering validation takes this a step further than just the validation tools of looking for missing values, information that's wrong. The engineering validation object, it's used to define a set of additional checks on the network data to ensure that it's consistent with expected engineering values. So if we create this validation group, we'll create a new validation, and we can go ahead and open this up and change some of this information, keep it just standard. One thing for this one, because we are working in Colorado, we want to update the node elevation out of expected range and make that 7,000, just so we don't get a bunch of errors just because we're working at a higher elevation. So you can change these values, see where it's modified by users. We're going to close this and save it. And then we will do one final validation, do engineering validation, and drag this in. And now, as we can see, we are getting some diameter flags that we can dive into a little bit deeper, giving different priorities, as well as some pipes height changes that we might want to check as well. The final step that we are going to show is within InfoWorks WS Pro. You also have the ability to create themes. So you can do this by creating themes within the model group, new themes, theme groups, or like the other options, we can go ahead and drag ones from a different project. We'll use a very basic pipe diameter. So now when we zoom in, we can see those labels that are built in. This can be used for results, for overviews of the system. Now that we've talked about the workflow and we've walked through it, I hope you see some of the benefits. Just an efficient model build, leveraging the available files, wanting to leverage those DWGs that you already have sitting around in order to build your model, and really improved collaboration, not just across teams, but across projects, leveraging the tools within InfoWorks WS Pro. We hope you enjoyed this video, and we hope to see you next time.